Okay, so this is problem 11.2.17, and they ask us, what is the probability of getting either a sum of 8 or at least 1 4 in the roll of a pair of dice? Okay, so what you have to think about in this problem is the fact that there's the word or in here, and I'm going to write it out actually so we can look at it a little more clearly. So what's the probability of a sum of 8 or at least 1 4? And this is, in a roll of a pair of dice. The key word here that we have to notice is the word or. And what that's telling us is that we're going to be joining two different probabilities, and then we're going to have to think about their intersection and subtract off their intersection. So that's this formula right here, and it's not even really something that you have to necessarily memorize, but it's good to understand it. So the probability of A union B is going to be equal to the probability of A plus the probability of B, but then we have to subtract off their intersection. Okay, and that formula I think was presented in this section. So remember that or and union go together, that those words go together. So essentially we're going to look at the probability of the first thing that they're asking us for. We're going to add that to the probability of the second thing, and then we're going to see if those two situations overlap, and that's the intersection. And if they overlap, then we're going to subtract that, because essentially if they overlap, we would have counted it twice. We would have counted it here and then here, so we need to take that away. Okay. All right, so the first thing is, let's just look at the sum, getting a sum of 8, the probability of getting a sum of 8. So if you think about, let's think about the desired first, and we could call this our event A here. So the probability of A is always some desired value over some total value. And so let's think about the numerator first. So if you want to get an 8, you could roll a 4 and a 4. And because we're looking at a sum of 8, you could roll a 5 and a 3, or a 3 and a 5, and you could roll a 6 and a 2, or a 2 and a 6. Okay, so you actually have 5 different options here of what you can roll that will give you a sum of 8. So your desired number of ways to get the sum of 8 is 5. And then the bottom part of the fraction is always the total number of ways to get this. Well, there's 36 different ways to roll a pair of dice. You have basically the basic counting law. You roll one dice, you have 6 options of what you're going to get, 1 through 6. You roll the second dice, you have 6 options, 1 through 6. Okay, so the probability of event A here is 5 over 36. Okay, so let's look at event B, and the event B is rolling at least 1 4. Okay, well, if you roll at least 1 4, then what you're thinking about is the list of rolling at least 1 4. You can make that list. You can see the pattern here. You can roll a 1 with a 4, you could roll a 2 with a 4, a 3 with a 4 with a 4, because it says at least 1 4. You could roll a 5 with a 4, and then a 6 with a 4. And then you could do all of these again, around, or excuse me, not again, but you can do them in the reverse order. So you can think of rolling a 4 and a 1, and a 4 and a 2, a 4 and a 3. We're not going to count 4 and 4 again, though, because those numbers are the same. So we could roll a 4 and a 5, and a 4 and a 6. Okay. So that's the desired number of ways to get at least 1 4. And so if we count these, we've got 4, 8, 11. So the probability of event B here would be 11, and total number of ways is 36. Okay. All right, so now what we want to do is we want to actually add these two together, but we also need to take into account their intersection. And if you take a look at it, they do have one intersection point, and that's the fact that we counted this 4 plus 4 twice. Okay, so we would actually need to subtract off 1 out of 36, and that one situation is the situation where you have a sum of 8 and at least one of them being a 4, and that's this situation right here, 4 plus 4. Okay, so Um, okay. So if we continue with that, then this is going to be 5 over 36. We need to add the second situation, 11 over 36, but then we're subtracting 1 over 36, and that is the intersection of these two events. If you add the numerators here, you have 16 minus 1, which is 15 out of 36, and if you reduce that, 5 will, actually we'll take 3. 3 will go into 15 5 times, and 3 will go into 36 12 times. So your answer there would be 5/12.